Hot work is a significant cause of fires and can potentially be catastrophic. This is because when hot work is taking place, there's a source of ignition present, so flammable materials nearby could be ignited and allow fire to spread, sometimes unnoticed. Hot works could be any temporary activity or task that involves open flames or the production of heat and/or sparks, such as cutting, welding, grinding, or felt laying. Regardless of whether the work is being undertaken on a new build site or involves alteration, refurbishment, or maintenance, including the installation or decommissioning of plant, the requirements remain the same. The film is in 3 sections. Please watch each one carefully. There have been a number of high-profile major fires which have started as a result of hot works in buildings which at the time were undergoing construction, renovation, refurbishment, or repair works. The fires put the lives of workers and members of the public at risk, as well as causing significant financial harm to the companies involved, and causing huge delays to the building projects themselves. But it's not just life safety that is an issue. Fires resulting from careless hot work activities may also cause extensive damage to property, not just to the building being worked on, but can lead to other buildings nearby also becoming involved in the fire. The sources of heat most commonly involved in hot work processes include gas or electric welding and cutting apparatus, blow lamps and blow torches, hot air guns and blowers, bitumen and tar boilers, angle grinders and grinding wheels, brazing and soldering, and it includes the laying of roofing felts and similar materials. Temporary is the key word here, as we're talking about areas that haven't been set up specifically for hot works activities, but are created for a short, fixed period as part of a building, refurbishment, installation, or maintenance project. Where any type of hot work is undertaken, the risks of fire are increased, and anyone involved in the process may be held legally responsible if they aren't managed properly. When involved in any form of hot work task, it's important that the nature of fire and the various mechanisms by which it may spread are understood. Fire is a chemical reaction between oxygen in the atmosphere and a fuel, such as wood, plastic, or gas. For the combustion reaction to occur, the fuel must be ignited. Once a fire is alight, the reaction will keep going as long as there is enough heat, fuel, and oxygen. This is known as the fire triangle. A fire is extinguished by the removal of any one of these 3 essential elements. Once a fire starts and has an adequate supply of oxygen in the air, it has the potential to spread, particularly if surrounded by combustible materials. This can be by convection, conduction, or radiation. Convection. When heated, air expands, becoming less dense than the surrounding atmosphere, and mixed with gases produced by the fire, moves upwards, forming convection currents that can carry with them heat and smoke and potentially harmful gases. In this way, superheated gases and smoke can travel through a building in the hot air currents, often igniting more combustible materials and causing the fire to spread. This fan heater is creating a forced convection current, and the heat created is enough to ignite combustible materials nearby, despite the fact that they have not come directly in contact with the flames. Conduction. Although some metals such as steel will withstand the effects of great heat without igniting, their presence will not necessarily slow or stop a fire. This is because metals are very good conductors of heat. Heat energy can be conducted along or through an object from the hot areas to the cooler areas. A steel beam heated at one end will carry the heat along its length and may cause combustible material remote from the fire or initial source of heat to be ignited. Similarly, a metal door or partition being heated by a fire on one side may ignite materials in contact with its other side. Radiation. Objects in the vicinity of a fire are exposed directly to the radiant heat from its flames. In the same way, we can feel the heat from the sun. The heat from the rays can be absorbed by combustible materials, which cause them to increase in temperature and potentially ignite. A building on fire can set light to another nearby building by radiation alone. The Hot Work Permit is an important document which proves that potential risks have been considered, actions taken to minimize them, and protective measures put in place. It forms part of meeting your responsibilities for the safety not just of everyone on the site, but also any members of the public who may be affected by your actions. These must be used in every instance and however quick the job. There are no exceptions. Every hot work job requires a separate hot work permit, and each permit lasts for only one shift before it must be reassessed and renewed. Copies of the permit should ideally be held by the person authorizing the work as well as the person doing the hot work, and a copy should also be displayed at the hot work site. The hot work permit is there to ensure everyone's safety, so please take it seriously. When planning any hot work activity, always consider if the work can be completed another way without the need for hot works, or completed off-site. If not, try to undertake the work in a dedicated hot works area or a location specifically prepared for the task, such as this one. Before starting to fill in the hot work permit, the senior person responsible for the site will first of all explain how to raise the alarm, where the nearest escape routes are, and the actions to take in the event of a fire. Hot work can be catastrophic. When hot work is taking place, there's a source of ignition present, so any flammable materials could be ignited. They could smolder unnoticed, or they could flame, or a flammable gas could be ignited. It is therefore important to make sure that there is a safe means of escape from anywhere where there is hot work taking place. Escape routes should be clearly identified and properly marked, and be subject to good housekeeping and tidiness. Highlight the requirements in terms of personal protective equipment, PPE. If appropriate PPE is not available and used, work may not be allowed to start. Describe any specific risks on the site that need to be considered, such as the location of combustible insulation, or explaining the location of voids, such as large cavities, or features like service risers. The first part of the process is to complete a simple checklist. All those involved should visit the site to make sure that the area where the hot work is to be undertaken is appropriate and made safe. Those doing the work are competent, have appropriate PPE and safety equipment, and know how to use it. To minimize the potential for false alarms, fire detection systems should be impaired locally following the site's documented procedures. This must be noted on the hot work permit, and these systems must be re-enabled as soon as the hot works are complete. It's important, however, that sprinkler systems are kept operational. Once the checklist has been completed and any actions required to make the work area safe have been undertaken, the permit itself can be completed and issued. The permit describes the work that is going to be done and the location. It will also describe how long the work is planned to take and, importantly, indicates the period of time after work has been completed that a fire watch must be maintained. The permit will be time limited. It's important to remember that a fire watch must remain in place for the whole duration of the works, including across breaks and lunch times, and for at least 1 hour after the work is completed. The hot work permit may show a longer duration for the fire watch in some circumstances. One of the most important things affecting the safety of hot works is the correct preparation of the work area. A good way to visualize this is to imagine a sphere with a 10-meter radius centered on where you intend to carry out your hot works. Within that area, you must clear the work area of all combustible materials. This includes waste materials, building materials, or packaging. Cover any combustible materials or surfaces with specialist certified flame retardant materials. Protect voids in floors or other combustible building construction which cannot be moved. Remember, if it's overhead work, the distance may need to be more than 10 meters to cater for areas beneath, and sparks and such like may fall further. Remove any flammable liquids or gas cylinders. Great care should be taken when undertaking hot works in areas where an explosive atmosphere may exist. This is particularly important where work is being done on drums or vessels that may have contained a flammable liquid or other hazardous substance. Where a hazardous atmosphere is suspected, air samples should be taken and work only allowed to commence when the atmosphere has been certified to be non-flammable. Good ventilation should be provided in all areas where hot work is to be carried out, as procedures may produce large volumes of smoke and fumes. Similar risk may exist where dusts are present in suitable quantities in the atmosphere, such as from milling or woodworking. Work should only be undertaken once specialist advice has been sought from a competent person and appropriate actions taken to ensure the environment is safe. Don't forget, flames or sparks may travel through openings in the wall or floor or unseen behind flashings or coverings. Heat can be carried along materials, particularly metal, to ignite combustibles in cavities or on the other side of walls or floors. Be aware that where insulating materials form part of the building structure, they may be combustible. There may also be combustible storage, cable trays, conveyor belts or systems, line piping or chutes that you need to be aware of. Certain materials and types of construction offer greater risk of ignition, such as where timber frames, SIPS panels, and other types of modern construction methods are utilized. If there is any doubt as to the type and combustibility of insulation and/or construction materials, then it is safest to assume the worst. In such circumstances, it may be assessed that hot works are not appropriate, and an alternative means of completing the work needs to be implemented, or the hot works may need to be carried out elsewhere. Where alternative approaches are not practicable, appropriate precautions must be taken. The use of tar boilers and felt laying work also present a series of significant risks. If working on a roof, the tar boiler should be set at ground floor level, not on the roof, unless it is more dangerous to do this. In all circumstances, the boiler must be stood on a non-combustible base or surface. The gas cylinder, once connected, must be kept a minimum of 3 meters away. And the boiler must be supervised at all times by an experienced operator. Wherever possible, flame-free equipment should be used in preference to naked flames. There are several modern devices which are proven to work effectively when undertaking roofing work requiring the application of heat, but which do not require the use of naked flames or flammable gases such as propane. This equipment utilizes electricity to generate sufficient heat, which can be more accurately applied locally. This minimizes the potential for unwanted ignition of materials which may be hidden behind flashings, for example. There is also no need for the use of fuel gases such as propane, which again minimizes fire risk significantly. Removing the need for compressed fuel gases on site also means that in the event of a fire, the fire and rescue services can act without the delay which might be caused by the need for long-term cooling of gas cylinders and imposition of an exclusion zone. Whilst not directly related to the safety of a site, it is also worthwhile recognizing that the use of flame-free equipment is likely to cause less damage to the environment. If it's not possible to use flame-free equipment, the Safe to Torch website provides further guidance on the safe use of torches on roofs. While the hot work is being carried out, a competent and trained fire watcher should monitor the work area and surrounding areas that may potentially be affected by heat or sparks. They should have at least 2 appropriate fire extinguishers to hand and be competent in their use. These extinguishers should be additional to the existing provision in the building or area. If a fire involves flammable gases, it is important not to attempt to extinguish the flames until the gas supply has been shut off. Depending on the nature of the work and the building layout, multiple fire watches may be needed to keep watch on floors below mezzanines or through walls or voids. Once the hot work task has been finished, all the hot work equipment must be returned to a safe and secure storage area. The post-work fire watch then begins. During this time, the work area must be monitored constantly for fire and/or smoke. The length of time that this post-work fire watch period must continue will be given in the hot work permit, but should never be less than 60 minutes. Fire watches must continue during breaks, lunch times, and at the close of work. Hot work areas must never be left unattended. This is a major cause of fires developing unnoticed. In some circumstances, a further period of fire and smoke monitoring will be required. The duration of this monitoring will be specified by whoever authorizes the hot work permit. The use of oxyacetylene welding equipment presents a higher risk due to the nature of acetylene gas, which can be highly volatile in certain circumstances, and easily forms an explosive mixture with air if released. Similarly, if an acetylene cylinder is involved or likely to become involved in a fire incident, fire and rescue service operational activities are likely to include restricting access to the site and areas around up to 200 meters, until they can ensure the situation is safe. Wherever practicable, alternative fuel gases such as propane should be used instead of acetylene to reduce the risk. Indeed, many organisations no longer permit the use of acetylene on their premises. To recap, when doing hot works, think about the hot work permit, why it's important and what it actually means. It's there for your safety. Carefully choose the area where you're going to do the work and make sure it is safe. Work safely, using well-maintained equipment which is appropriate and of the correct standard for that piece of work. Always use the proper working methods. Electrical equipment should be PAT tested. Gas cylinder supply hoses must be free from damage and in good condition. Regulators must be undamaged. Flashback arresters and non-return valves should always be fitted, and cylinders should be kept upright and secured to prevent them falling. Check the job and the area around it for fire risks after you finish, taking photographs and thermographic images where appropriate. And don't leave the site until the permit and job have been signed off. The reason for using hot work permits is to ensure your safety and that of others who may be affected by a fire. The requirements are simple and practical, but hot work should only ever be undertaken where less hazardous alternative approaches are not possible. Following these simple rules will also minimize risk to work schedules and livelihoods.